Today we'll be talking about use cases, specifically the orders and inventory management use case. In this video, I'll show you how to do that in CockroachDB and any considerations you might need to make with regards to resilience, scalability, consistency, and multi-region data placement. Your application needs to be resilient, and CockroachDB is highly resilient to multiple types of failure. Let's assume in this scenario that we're running CockroachDB across 3 availability zones within a single US region. If any of those availability zones go down, CockroachDB will remain online because it's still able to achieve quorum between the remaining nodes. When the availability zone comes back online, so does the CockroachDB node within that availability zone, and data is up-replicated back to that node from the other nodes. Just as CockroachDB is able to survive availability zone failures, it's also able to survive regional and cloud failures via the same mechanism. Let's now assume that instead of running across one region in the US, we're now running across 3 regions in the US. If any of those regions become unavailable for any reason, CockroachDB will remain online just as it did in the availability zone scenario. The system also needs to scale horizontally. If on day 1 you have 100 users of your system, that's very different to 1 million users in a few months or a few years from then. You need to be able to scale with your user base. And there needs to be 0 downtime between migrations or schema changes, etc. This isn't the kind of system that can go offline for maintenance and leave your users hanging. CockroachDB offers both scale and consistency. If you're unable to prove that data is being consistently stored and processed, this could mean a failed audit. New users and markets can be reached as your application and user base grow. Scaling a CockroachDB cluster doesn't require downtime, and data can be pinned to geographic regions, helping you achieve regulatory compliance as you scale. In any system whereby you're browsing for and/or purchasing products, you'll be interacting with this use case. But there are other places where this use case comes into effect. For example, warehousing, distribution, and manufacturing. It all boils down to a product and the amount of inventory you have for that product. In today's demo, we'll be focusing on 3 different things. The first is product browsing, the ability to browse for a product or set of products, the ability to add a product to a basket, satisfying the e-commerce use case, and checkout, the process of converting a basket into a purchase. Architecture-wise, I'll be simulating users around the world in the Americas, Europe, and Asia. Requests will be routed to the user's nearest application and database. We'll begin by setting up the environment. I'll spin up a multi-region CockroachDB cluster across the US, Europe, and Asia. With that set up, I'll export some more environment variables that have been outputted from the Terraform run. And I'll spin up the CockroachDB database, tables, functions that I'll be using for adding products to basket and checking out, and generate some data before connecting to the cluster. With the database side set up, I'll create the application side now. I'll create a fly.io application called CRDB ecommerce with 3 environment variables, one that connects a client to the EU database, one to the US database, and one for the APAC database. CockroachDB does have a globally aware load balancer, but just to keep things explicit, I'm separating the URLs by their regions. I then deploy one instance of the application before scaling it out across Frankfurt, Ashburn, Virginia, and Singapore. While that's deploying, I'll show you what the code looks like. I'll create a database called store that will run across the same regions I've deployed my cluster to. I'll create a customer table whose data will reside close to the customers themselves. A product table containing data that globally identifies every product, and then market-specific versions for those products, referencing the product ID with a region-aware column that switches on the market. Wherever we see, for example, Germany, Spain, France, Ireland, or the UK, we'll store that data physically in Frankfurt. There's a stock table that keeps track of local stock. There's a basket table that stores customer baskets close to where the customers are. A purchase table that stores customer purchases close to where the customers are. And a table that I'm using to simply say, given my region, what markets am I running in? More of a debug helper. I've created 2 functions for this demo. One allows a customer to add a product to a basket, and another allows them to check out their basket. This is quite a heavy operation. Firstly, it asserts whether a customer has anything in their basket and raises an exception if there isn't anything. Next, it performs one last stock check to ensure there's enough inventory of each product before allowing the user to check out those products. It raises an exception containing the IDs of any of the products that are out of stock. Next, it creates the purchase, removes the stock from the stock table, and then clears the customer's basket before returning the UUID of their purchase. The code looks like this. I fetch the database URL from the environment. I connect to the database and test the connection. I load my region from the database by using select gateway region, and using that region, I'll select all of the markets that I have in that mapping table for that region, allowing me to create a customer in each of those markets. For each of those markets, I'll spin up a worker by creating a customer in the database, and then at regular intervals performing a browse, basket, and checkout operation. After every second, every customer will make a browse request to the database. Every 10 seconds, they'll add a product to their basket, and every 30 seconds, they'll check out anything that's in their basket. With all the simulated users up and running now, let's see what kind of latencies they're getting in each of their respective regions and markets. First, I'll look at the Frankfurt region and any customers that are running against that region. We're seeing browse latencies of around 6 milliseconds, basket latencies of around 12 milliseconds, and checkout latencies of around 50 milliseconds. Let's have a look at users in the States. We're seeing around 7 milliseconds for browsing, around 12 milliseconds for baskets, and around 50 milliseconds for checkout. Let's check on the APAC users. They're seeing browse latencies of around 6 milliseconds, basket latencies of around 12 milliseconds, and checkout latencies of around 50 milliseconds. As we've just seen, it doesn't matter whereabouts our users are based, they all get a great experience of the application thanks to the way that CockroachDB is distributing their data and pinning it close to them. Being a database that not only scales but does so consistently means that in our inventory management e-commerce example, we're never going to oversell a product. So you can harness CockroachDB for these use cases with confidence.